So can anthelmintic mitigation measures benefit the environment through the employment of grazing strategies and dung beetles? Just rolls off the tongue, doesn't it? Hi, my name is Bruce Thompson, and I would like to speak to you today about some key findings that I found during my Nuffield research, which started off travelling around southern Australia and Tasmania before a changing world retired me to completing my topic virtually fueled by banana bread. Returning home from college, I decided to increase the stocking rates and stock numbers on my farm, and soon I realised that we were intervening more with our parasites and witnessing more disease. So one day myself and Dad were having a conversation while we were worming our animals, and one thing we did actually manage to agree on was that we were heading the wrong direction with our management. So I decided to look at this a bit differently. So my first challenge as a Nuffield scholar was to figure out what anthelmintic resistance was and how to pronounce it. Anthelmintic resistance is the ability of a number of parasites to survive a worming event. You see, every time we worm our animals, a certain number of parasites get left behind unscathed. Now, when this percentage of parasites hits a certain threshold, it is deemed that resistance is present. And every time we worm our animals thereafter, the percentage increases until the worming event has no effect. And then this happens. These two items collide. So we had to figure out in the country what the national picture was. So I only had to go as far as our research organisation, Chagas, and the Department of Agriculture, who are both reporting on increased cases of resistance throughout the country. We literally are heading up the creek. So I could see that we were losing the battle of parasites by trying to kill them in the animal. So I decided to look at the free-living stages, that is, out on pasture. So I travelled to Tasmania, where in a relatively similar climate to our own, anthelmintic resistance is well developed, leaving some farm operations unviable due to ineffective parasite control. I met with Paul Nylon of Nylon Vet Care, who along with his clients is adopting a grazing strategy called smart grazing. This involves using older, more resilient animals to hoover parasites off of pasture. The basic process is these animals are given a combination of wormers before being released out onto a paddock, cleaning and hoovering up all the parasites before being removed, before the parasites are allowed to complete their life cycle. This leaves the pasture clean for more susceptible animals following thereafter. This is colloquially known as the napalm approach. I could see how this works, but is there another way? So bringing this idea back home, I decided to develop a grazing strategy called traffic light grazing. This involves mapping the risks around the farm and using the levers we have to pull, that is, more resilient animals, silage cutting, duration, and reseeding. We're able to identify which paddocks to give to which animals. This has made a significant reduction in intervention on our farm. My own dairy discussion group, the O'Moore Dairy Group, has been successful in gaining funding through a European innovation partnership to adopt this process on their farms. But thinking about this more, I wanted to see how we could get rid of these parasites off of pasture. So talking to Dr. Sally-Ann Spence of the University of Oxford, she got me thinking that dung beetles were public enemy number one for parasites. So I talked to Dr. Brian Resands of the University of Bristol. At the end of a 10-week trial, Brian concluded that dung beetles reduced parasite loadings by 30% on pasture in normal field conditions. So if this is the case, why are we seeing these problems? Well, Brian also informed me about the negative effect that anthelmintics and synthetic pyretides, they're common wormers and fly control products, the effects that these had on dung beetle populations in trials that she conducted. And the reports were startling. John Finn and Tom Gittings, both Irish researchers, estimated that the survival rates of dung beetles were down to 15% when ivermectin had been administered to animals. So in a bid to control parasites, we're killing the one lever that nature is providing us for free. So I decided to travel to Australia to look at the dung beetle husbandry down there. In the late 1700s, when white man landed with his cattle and sheep, he forgot to bring his dung beetles with him. And the native dung beetles that had evolved around marsupial dungs took one bite out of these new dung pats and thought that they tasted like crap. The effect was that dung pats took years to disintegrate on pasture, leaving all sorts of environmental hazards. Industry and government funded together a scheme over the last 50 years whereby dung beetles have been imported, mass-reared and released out onto pasture to bury these dung pats into the soil. I travelled with Bernard Dobe of Dung Beetle Solutions. Bernard's career has revolved around importing beetles and supplying them to farmers throughout Australia. He is currently working on his last species to complete a full year-round presence of dung beetles on pasture to make worming a rare event. I visited Mark Higgins, a consultant with the Florio Beef Group. Mark's farm has been a release site for dung beetles over the last 20 years. He showed me a dam at the bottom of his farm. The water level in his dam is decreasing every year with the same rainfall. Mark is putting this down to the effect that dung beetles have, leaving earth-burrowing holes in the soil, increasing the water infiltration rate when it rains, and leaving less runoff into the water. Is there something we could learn about here? I travelled to North Tasmania and met Dr. Graham Stevenson. Graham brought me out to a research farm, and I was absolutely gobsmacked with the level of activity of dung beetles. We went out onto a paddock that had been grazed by the 200-cow dairy herd 3 days prior to us being there. There was no dung pats left on the field, all buried into the soil with the parasites, fly eggs, nitrogen, phosphorus and potassium left at the roots of the grass where it belongs. Graham also informed me how the dairy industry and county councils funded a programme to bring in these beetles, mass rear them and release them into catchment areas to solve algal bloom issues in waterways. Another lesson for us to learn. Bringing these processes back home, I decided to see if our native common dung beetles were suitable for mass rearing. However, with the lack of funding, I had to rely on cheap labour in the form of 2 PhD students. This was successful, not the labour bit. That was definitely not successful. I found that I was actually able to mass rear the dung beetles. This year, and with the help of a crazy sheep farmer from Bennett's Bridge, Susanna Crampton, I caught a team of rarer earth-burrowing beetles that are currently in an incubator on my farm, burrowing a full dung pat within 3 days. No need to worry about parasites there. This caught the attention of Dr. Gillian Gilbert of the Isle of Islay, off of Scotland. You see, dung beetles are at the bottom of the food chain, and they are an important food source for birds, bats, foxes and badgers. And Dr. Gillian Gilbert concluded that the sharp decline in the chough bird population on the Isle of Islay is due to a combination of the use of synthetic pyretides and triclobendazole in sheep. These are common fly and fluke products that we are using on our farms. Together with some RSPB staff, we have placed some breeding cages around the Isle of Islay. We are finding that if we capture 25 adults, we are getting over 400 offspring. One step in the right direction for reversing biodiversity decline. Now at this point, I thought that my findings were done and my Nuffield report was finished. However, I have to report on something strange, and that is the appetite for change that I witnessed amongst farmers and other stakeholders. Television, webinars, radio, newspapers, all showing an interest in change and how positively our animals can affect the environment. I joined up with a team of entomologists, conservationists, farmer and a vet to make a website, Dung Beetles for Farmers, to inform people who could be more dung beetle friendly. This year at a trade show in the UK, we had a stand. Throughout the course of the show, we were bringing people out to pasture to show them what was going on in the dung pats. This picture really captures the essence of what we witnessed. Over 200 people following us out to pasture. Men, women, children, farmers, vets, ecologists, all walking on one road, looking for change. Let's call this a movement in the field. So to conclude, anthelmintic resistance is posing a real threat to animal performance, and it's a sleeping giant that is just awakening. Our modern parasite control strategy is unsustainable and is having a negative effect on biodiversity. However, I also believe that anthelmintics have a very important role to play in our parasite management going forward, so they need to be protected in the same way as our antibiotics. Dung beetles have the ability to reduce parasite loadings on pasture. And as I said, there is an appetite for change. My recommendations are that farmers and vets come together to adopt a diagnostic approach on farms to use as much anthelmintics as is necessary, but as little as is possible. Playing it safe is a dangerous game going forward. Collaboration of all stakeholders to share information through a central hub to allow forecasting and trend setting and warnings of parasites. A beetle mass rearing programme to be funded by industry and facilitated by assets and the National Park and Wildlife Services, concentrating on catchment areas. And the HPRA to label synthetic pyretides and anthelmintics, informing the users of the environmental hazards that these products pose. And finally, to go home and look at your pats. Not your pats, your animals' pats. So I would like to give a big pat on the back to the board and our scholarship sponsors for entrusting their resources in me over the last 2 years. And particular thanks to John and to Karen and my fellow scholars and my mentor Kevin Toomey, who unfortunately couldn't be here today. But I would like to also give a big thank you to people who are working behind in the background at home, and particularly my wife and Laura and my 2 PhD students for putting up with me over the last 2 years. Thank you.